We've learned a lot about the scientific method so far. This process involves several steps: making observations, asking a scientific question, formulating a valid hypothesis, testing that hypothesis, analyzing the data, drawing conclusions, and communicating your results to the scientific community. These steps work best when you go through them in order. For example, it's difficult to ask scientific questions if you haven't made any observations. You're also going to run into trouble if you try to formulate a hypothesis without a scientific question in mind. And good luck analyzing data without an experiment to generate them. But while the order of the steps is important, this entire process is iterative or repeatable. Once you run your experiment and gather and analyze your data, you may make some new observations that lead to new questions. If this happens, you may decide to rerun the entire experiment, certain parts of it, or you may have an entirely new experiment in mind. Or perhaps your experimental results weren't clear or failed to answer your original question. In this case, you may not need to change your question at all, but instead you can just tweak certain parts of your experimental design to better address your hypothesis. Regardless of why you do it, you can go back to different steps and begin again from there, making this process an iterative one. Let's look more closely at how this process works to better understand why scientists often return to certain steps and repeat them. Let's say that you have a dog and you observe that she really likes the treats you give her. This leads you to ask, using these dog treats, how long will it take to train my dog to sit? You have a very smart dog, so you hypothesize that with these dog treats you can train her to sit in an hour. Next, you'll run your experiment. Train your dog to sit. You work with her, and in about an hour she understands that she will get a treat if she sits right away when you tell her to. Bravo! As you were training your dog, you noticed that she followed your command more quickly as time went on. That is, at first, she didn't sit at all because she didn't know what you were saying, so you helped her through the motion. About halfway through the training, it would take her about 15 seconds to sit after you gave her the command because she still wasn't quite sure about the connection between the word sit and the action of sitting. But by the end, she sat right away because she understood you and really wanted that treat. But here's where the fun comes in. Since she was so good at learning this first trick, you now want to teach her other tricks. Now you wonder how long it will take her to learn lie down, and you can begin the whole process again. You may even get into more complex tricks like jumping through hoops, catching a frisbee, or turning in circles. As you can see, just because you follow the steps of the process doesn't mean that you have to stop once you reach the end. In fact, if when you were training your dog you noticed that she just wasn't getting this whole sit thing, you would make observations that would hopefully lead you to new questions. Is there something about the way that I'm saying the word sit that is confusing? Am I giving her a consistent signal each time? Is the type of treat important? Should I offer her something tastier or bigger? You don't have to go through the entire process. You can stop and adjust anywhere in between. If your hypothesis isn't quite right, maybe you need to go back and adjust your question. Or maybe you need to make new observations because you missed something the first time around. While training your dog isn't really a scientific experiment per se, it does follow the same path as the scientific method. Starting with observations, scientists see, hear, smell, taste, and feel the natural world around them. From these observations, they ask questions about the who, what, when, where, and why of it all. Then they formulate valid hypotheses, run experiments, analyze their data, and report their results to the scientific community. These steps of the scientific method are best followed in order, but that doesn't mean that the overall process or even individual parts of it can't be repeated. Experimentation often leads to new observations and questions, which starts the whole process again. Or you may find that something isn't working, so you go back one or two steps and refine certain aspects. Regardless of whether you repeat one step or all of them, it's in this way that we can see how the scientific method is an iterative or repetitive process that helps scientists learn about the natural world.